So we've done the encoding of a plain text into a ciphertext using the monoalphabetic cipher. In this video, we're going to do the reverse. We are given a cipher and we have to decode it back to the plain text given the key. I have reused the same key and the ciphertext that we had generated from our last video here. And this time around, as you can see, the plain text string starts off as empty, while the cipher string is full of the ciphertext, right? We're going to try to code up how to do the decoding now. So first thing first is we still have to do the same pattern, which is to iterate through every single character in the string. So we'll still need that. Let's put that down. But this time around, we are going to iterate through the cipher string rather than the plain text string. And we still want to process only lowercase ASCII characters, and we want to pass through all punctuations, all spaces. So we will still have that conditional to do a check. Okay, we have already imported the string library. And so we have this. All right, I'm just gonna make a skeleton, so I'm gonna use a placeholder statement called pass. And we know that if it's not an ASCII lowercase character, we are going to just pass it straight to the plain text string, append it to the plain text string, right? So that takes care of that. Right, so how do we then process our string, our character, from the encoded state to the decoded state? When we were doing the encoding, we were very lucky that the alphabet is already, in order from A to Z, and so we could easily find the index of the character by looking at its ASCII value, right, and then minus of the base 97, and that will give us the position of that character in the string from A to Z. Okay, we don't have that here because in our the key here is all jumbled up. It's not in order. So that means that we'll have to find where our position of the character in the key string using another method. And we are actually going to use a built-in method that applies to lists and sequences in Python, and that's the find method. So what we can do is we can go, we can call on the key list, a string is just a list, and say like find this character C. And what the find function does is it's going to return to you the index of the first time that this character appears in the key string, right? And if you cannot find it, it will actually throw an error. But we are very certain that it can find it because of two things. Firstly, we have gatekept this code such that we know for a fact that the C character is an ASCII lowercase character, and we have also ensured that the key string contains the characters, all the lowercase characters from A to Z. So the find function is not going to throw an error. We don't have to handle it in code. Right, so we're going to install that inside a variable. And I think I'm just going to print it first so that we know we can just do a quick check that everything is working fine. And it's always a good idea to run your program as you're developing it, so that you can just make sure everything is on track, right? So we can see here, it's no errors were thrown. Every single C characters return an index. We passed through the strings. We didn't the spaces. We did not print them out. That's fine. And everything's between 0 and 25. Okay. Now this index actually, now we can use the fact that the alphabet is um, it's from A to Z and it's in order. Now we can use that fact. We use that fact when we were encoding easily. We couldn't use it here in the beginning and so we had to use the find function. But now we can use the fact that A to Z is ordered from 0 to 25, right? So we can actually recreate the character, the decoded character, um, by saying create the character from the index value, and we have to add on the base position of the A letter, right? So that index is going to give us the index relative to the starting position A. So we have to add 97 to it so that it will give us one of these numbers from 97 to 1 to 2. And then we can call the CHR function to return us the character corresponding to that number. So that's what this does. And we will just add it to our plain text. I'm going to use the shorthand here for appending it to the plain text, right? And I think this should work. So let's do a print. Let's print the cipher. And let's print the plain, our computed plain text. And we are hoping that this will return us the quick brown fox jumps over the lazy dog. Okay, so saved and run. Let's see what, oops, hang on, cancel. There's a S character here. Okay, let's run again. Yes, okay. Well, phew. It does work. There was no errors here. And there's nothing wrong with there being an error. You just have to go back to your code and figure out where your bug is and fix it. But here in this case, it works. We've managed to decode our cipher text using the given key. And you'll notice that it is similar to how we encoded, but there's some key differences. For example, the use of the find function was critical in implementing this program. So give it a go. Try not to refer to this code, source code. Give it a go on your own first, and then if you get stuck, then you can review this video.